Hello, my name is Dmytro Yakimenkov. Me and my colleague and co-author Galina Roizina, a consultant of UNECE and also expert of UNECE FACT, IMO, WCO, and OSGD. I would like to present our approach, how one can move from paper to electronic documents using UNECE FACT standards and data models. The brief roadmap for this presentation is a short introduction, information about practice of application in completed projects, approach description, extension of this approach, and the conclusions. The full version of this guidance is available in the form of report on the untitled.org site. More information about UNECE FACT and its activities you can find by the link provided. Also, it's highly recommended to familiarize yourself with the work of Dmytro and his guidance to standard. In this presentation, we will try to show you the approach from the point of view of our practical experience as a pod community system operator and single window system operator from the one hand, and as a result of a series of assessments executed for UNECE from the other hand. The project was carried out in cooperation with the Economic Commission for Europe and UNECE FACT as a part of the response to the COVID-19 crisis. The work itself is a logical continuation of the initiatives reflected in the recommendations of the previous UNECE Odessa workshops in 2019-2020 and is aimed at developing digital multimodal transport corridors in order to harmonize and standardize data exchange in international transport, trade, and logistics. There are 4 projects completed for the present time. You can access the full information on each of them on the untitled.org site following the links provided. In the scope of these projects, real business cases were assessed and also transport documents were mapped against UNECE FACT reference data model for multimodal transport, not only Ukrainian, but also from other countries along transport corridors. This work allows us to work out on practical approach how to create an electronic documents aligned with UNECE FACT standards and data models. Other details. As already mentioned in the introduction, the approaches to the creation of electronic documents based on the UNECE FACT data models are largely the same among various experts. In the following, we will use the step names given by David Roth in his standard guide as a general terminology. In particular, David suggests the following sequence of actions: gather examples, use cases, list of data attributes, mapping against MMT, outputs and questions. Also, we believe it's useful to separate the step creating an electronic documents equivalent as a deliverable of the process itself. As an illustration of the approach taken in our assessment and case studies showing some of the differences, we will use the International Road Transport Consignment Node, CMR. So, gather examples. To gather examples, one should refer to general requirements and also to real business examples. For CMR, this is first of all the Convention for International Road Transportation and also additional protocol for the Ecmr Convention, links provided. If you are doing a digitalization of some document, not as an academic assessment, you should have access to some real shipments with documents accompanying them. It's extremely important to start from harmonizing requirements on this step. Despite the fact that the CMR document is an international transportation document and in this regard, it must comply with the requirements of the countries involved in the transportation, and on the other hand, it's regulated by the convention. In real business transactions, there are a sufficient number of variations of the above of the form. This leads to the first interoperability issue already at the paper document level. Suppose for simplicity of solving the problem of creating of electronic document that the transport contract parties have agreed to use a certain form of paper CMR document as it happens in reality. Next step, use cases. This is next step in the implementation of an electronic document is then the next step in the implementation of an electronic document is the analysis of business transactions in which this document is used. In terms of the CMR, the IRO, International Road Union, recommended procedure for filling out the document is given in the guidance how to fill in the CMR consignment node, IRO model 2007. You can have a look on the full text of the link provided. At the same time, real business transaction impose certain features on filling out such a document. This first of all concerns commercial information, the cost and the terms of payment. Another sensitive point for business is the practice of using intermediaries in transportation. In this case, the main carrier often doesn't want to share information about the transport service buyer with his subcontractor. So some of the information is not filled in or is filled in a modified form. There is also a practice of requesting a CMR document from the government administrations and regulatory authorities. Despite the fact that by its nature the CMR is a private law document and as a part of the control procedures in most jurisdictions, the government authorities have the right to access only to a limited number of details from such a document. In the case of a paper document, it's not possible to implement such restrictions, which in turn leads to unwillingness of the participants in the transportation to enter details, information into the document. You can see an example of the real CMR node that has a lot of boxes left empty. Another important element of business analysis is how changes are made to and tracked in a document during its life cycle. On the figure, you can see an UNECE life cycle for CMR. At least 3 parties make their changes during the life cycle to document. Creation of a document by the sender or the transportation service buyer, amendment of the document by the carrier, its information about the lorry, the driver's name, the fact of acceptance of the cargo and comments on its condition, the driver's signature, amendment of the document by the consignee, its delivery information, the fact of acceptance of the cargo and comments on its condition, the signature of the consignee. In case of a paper document, this information is added to the original document at the time of the corresponding logistical event. For example, loading cargo onto a lorry. In case of an electronic document, additional issues can potentially arise. The information flow is separated from the cargo flow. This means that the electronic document is not transmitted synchronously with the movement of the goods. Thus, an electronic document can be available to all participants of the transportation at the same time or by any events or rules. In the digital world, there are several interpretations of the concept of original in relation to a digital asset. They differ from the all copies are original approach to the approach taken from the blockchain technology, so-called non-fungible token. Technological approaches to the very process of making changes to electronic document. For example, the source document is changed and a new document is created that refers to the source document, or the source document is embedded into a new one. The issue of a legal recognition of the changes made to the document. All these issues should be taken into account in the real projects. List of the data attributes. Based on the results of the analysis of business transactions with the assessed document, we can form a list of attributes or information entities for further formation of an electronic document. The full table is available in the report. As can be seen from the table, a number of attributes are elementary information entities. For example, the document number. Some are aggregated, for example, the party of the transaction, such as the sender or carrier. It should be also noted that some of the attributes from the document are not included in the table. As mentioned above, the analysis of practical business transactions has shown that there are attributes that are not filled in during actual transportation. On the other hand, attributes such as country, which are simply filled in with the name in paper document, are accompanied by a code in the case of an electronic document. The best way to start the mapping process is to select the appropriate subset of the data model for a particular business transaction or document. In case of CMR, the current version of such profile is available at the link provided. The mapping itself is convenient to do in Microsoft Excel using UNECE guideline structure for Ecmr. The subset for the Ecmr document consists of three main aggregated entities: document context, Ecmr header detail, and road consignment. The document context entity contains information about identifiers of transactions and business processes and is used in the context of certain electronic messaging procedures. For the purpose of the current description, this entity will not be used. The two other entities contain the attributes that we listed in the previous step, so the mapping process will be performed on them. The mapping is performed by sequential detailing or immersion into the structure of information entities of the data model. Let's start with the document header, Ecmr header detail. To understand the purpose of each of these entities, the model contains metadata that describes the types of data elements and basic information that such entity can contain. In particular, aggregated business entity Ecmr header detail contains 4 aggregated entities, that is additional particular nodes, issue location, message issuer, message recipient, and 4 base type attributes: identifier, document code, date time, and text. Each of the base type attributes also contains additional description to help identify the purpose of that attribute. In particular, exchange and document identification identifier is defined like you can see on the screen. Thus, we can make an informed decision to map this attribute to a Ecmr document number. Here. The identifier type has 2 elementary attributes: identifier content and identifier scheme agency identifier. Moreover, the first of these attributes, content, is mandatory. The second, identifier of the agency authorized for the identification scheme, is optional. This approach came to the data model from the UNECE core component library and applies to almost all identifiers. The approach is unique in its versatility and allows for interoperability between different parties in the supply chain, even in situations where such interoperability has not been previously agreed upon. In the context of an identifier, in fact, it's possible to specify who is responsible for the order in which such an identifier is assigned. Thus, following the logic described above, we can map the rest of the attributes from the header with the attributes from the paper document. Why are not all the fields mapped? In our example, there are a certain number of attributes that are not mapped against the data model. For example, a notified trade party. In the document that we used as a sample, this party of the transportation contract did not participate. Information wasn't filled in. At the same time, in other examples, it may be required. For this purpose, the segregated entity is present in the model and in the XSD schema. What to do if there are not enough fields? There are cases in real business practice when not all attributes of a real document can be mapped to the corresponding profile of the UNECE data model. There may be several reasons for this. Non-standard filling of the document, a new or non-standard business transaction, local requirements of the authorities parties to the transaction, and others. In any case, there are 2 options for further actions: making changes to the business practice and bringing them into line with UNECE standards and recommendations, or making changes to the data model profile for a particular document to update it to the current business practice. Creating an electronic document equivalent. This stage is not described in the guidance proposed by Dmytro. However, it seems appropriate to single it out separately. The list of attributes mapped with the entities of the Ecmr profile of the data model created at the previous stage, made using Microsoft Excel, clearly demonstrate the structure of an electronic document, but cannot be used as such. For this purpose, it's proposed to create an electronic document in XML format. The Ecmr document schema in XSD format is available by the link provided. The document schema consists of 24 files that reference each other. The documentation root starts in CMR 1PO XSD file. Omitting the type definition in the header, you can see that schema describes the Ecmr document as a type consisting of two nested types. Each of these complex types is defined in a file, reusable aggregate business information entity. In turn, complex types aggregated business entity refer to qualified and unqualified data types. The qualified data types include top-level information entities that describe certain roles in business transactions. For example, the party to the transaction that makes payment. Unqualified data types include entities that describe more general types. For example, the identifier, ID type. That we mentioned earlier. There are also 17 restricted coded lists provided. It's normal practice in CFAP to create restricted code lists for the main area, keeping the hierarchical link to the full code list to maintain changes. The structure of an CMR electronic document is quite complex, even for such a relatively simple document. The hierarchical nature of the files describing the structure greatly simplifies their maintenance within the framework of UNECE. However, it complicates their practical application in small projects. In order to create an empty XML document based on the structure we have, we can use one of those options. Manually describe the XML document based on the structure, manually transfer the structure definition to one file and then generate an empty XML document using one of the available generators. Use the open source development environment framework like Eclipse IDE, for example, or use one of the specialized packages working with XML, such as Alto XML Spy or GFX. More on that later. Having created an empty XML document, you can proceed to populate it. It should be noted that it's not necessary to fill in all the attributes available in the schema. In accordance with the specification, you can determine the obligatoriness of the corresponding attribute. For example, for the carrier, the nested information entities defined contact detail, postal address, tax registration, and trader registration are optional. Links marked as 0 to 1 or 0 to star. Thus, if necessary, branches of text related to these entities can be completely removed from the XML document without the risk of violating its compliance with the schema. Moreover, the attributes of the carrier entity themselves are also optional. Therefore, if necessary, they can also be omitted or removed from the document. Of course, from the point of view of a real business transaction, such a document will be meaningless. The carrier is one of the parties to the transaction and must be present in the document. However, from the point of view of validating an XML document according to an XSD schema, such document will be absolutely correct. As a result, the completed electronic document may look something like this. You can see the full document in the Annex 3 to the report. Some extra considerations. The XML technology can give you much more. First of all, the schematron, that is the simple and powerful structural schema language for making assertion about patterns found in XML documents. Schematron validation rules allow the author to specify helpful error messages, for example, which will be provided to the user if an error is encountered. Also, schematron can be used to check the validity and compliance of XML document to rules that goes beyond the possibility of XSD schema itself. To get more knowledge about it, please go to Schematron website. As an example of a real implementation of Schematron for electronic documents, one can cite the following for e-invoice documents in the Pitfalls ecosystem. Next one is visualization of an electronic document. XML transformation technology, or XSLT, allows you to describe the transformation of an XML document, or in general, any set of data that can be perceived by the processor as an XML document that is having a certain structure, into another XML document, into a text document, HTML, or PDF. An illustrative example of the implementation of such visualization by means of XSLT processor can be considered the implementation within the Dmytro project. The visualization script text is available at the link. It can be executed using any XSLT processor available on the internet. For example, this open source XSLT processor. We can put here the text of our Ecmr electronic document that we have made on the previous step and start the transformation. As you can see, the result is in the HTML form. We can save it as HTML file. Put here the extension HTML. And open it in the browser. Here you can see the result of our visualization. Outputs and questions. The approach described above is absolutely working, and with its help, we can create a really operational and practically applicable electronic document, harmonize it with the requirements of UNECE standards, and ready for use in multimodal transportation. This means that the information from such document can be used to create other documents in accordance with the requirements of UNECE. For example, when crossing a border or when changing modes of transport. At the same time, it's worth noting a number of pitfalls in the transition to electronic document management in the supply chain. In real business transaction, there is a difference in semantic. The same attribute in a paper document can be mapped with several attributes in an electronic one. In real business transaction, different requirements for filling in details in paper documents apply. In the electronic documents, as well as in the paper documents, there are problems related to the language of filling in text, details, and to the implied non-harmonized code lists. The transition to electronic documents had the problem of their legal recognition by the parties, including public authorities. Each of the barriers described above has specific solutions that are recognized by the industry to some extent. The development of new approaches and technological solutions is also ongoing. The described approach has some advantages and disadvantages. Advantages is the simplicity and speed of implementation, and also possibility of implementation without the need for significant changes to the existing software. Disadvantages is complexity that increases exponentially in the number of the data elements in the documents. Poor potential for automation and difficulty in maintaining and tracking changes. Thus, this approach is good for conducting proof of concept studies before starting the actual design of an information solution, as well as for small projects or academic assessments. At the same time, in the conditions of real transportation, a more technological approach is required that can ensure the satisfaction of the requirements for reliability, efficiency, and stability of the proposed solution.